students, welcome in my YouTube channel. In today's class, we will study about Schmidt reaction with their mechanisms. Now, what is the purpose of Schmidt reactions? Then we can write it by using a Schmidt reaction when we have a carboxylic acid. This carboxylic acid on reaction with a hydrozoic acid. When react with hydrozoic acid, it is observed that in the presence of hydrozoic acid in presence of sulfuric acid. When it reacts in the presence of sulfuric acid, it gives a primary amine with one carbon atom less. It is observed that it gives a primary amine. Whatever primary amine obtained, it has a one carbon atom less. So we are getting a primary amine from carboxylic acid by using a Schmidt reactions. Okay. Now we can write in this way that whatever carboxylic acid we have, this carboxylic acid, we are reacting with this hydrozoic acid N3H. Now we are using concentrated sulfuric acid. In the presence of concentrated sulfuric acid, temperature approximately 160 degrees Celsius is required. When we hit this reaction mixture, we are getting a first primary amine and we are getting two byproduct. One is carbon dioxide gas and second is nitrogen gas. So it is observed that this acid can be converted into primary amine by use of hydrozoic acid and sulfuric acid as a catalyst. So how this reaction occurs? This can be understood by using a mechanism. But to understand mechanism, first we will understand about what is the structure of hydrozoic acid. Now it is N3H, hydrozoic acid, nitrogen. We can write in this way, it has this type of structure. Now here nitrogen is a non-bonding electron pair, it has a positive charge and it has a negative charge and electron. Now this has a resonating structure, so another way we can write in this way, this nitrogen having a triple bond with nitrogen, it has a positive charge. Now this nitrogen having a two non-bonding electron pair and negative charge. So now we have taken this carboxylic acid. Now this carboxylic acid, it is observed that in the presence of acid, it undergo protonation reactions. So in a reaction medium we have sulfuric acid. The sulfuric acid gives H plus ion. Whatever sulfuric acid we have, the sulfuric acid produces H plus as well as it will be giving us HSO4 minus. So now this H plus ion will approach to this oxygen. So when H plus ion approach, it give electron pair to, it will approach to H plus ion. So this pi bond electron transfer on oxygen and oxygen give electron pair to H plus ion. And as a result, we will get this type of structure. Here carbon having a positive charge, here hydroxyl group 1 and here there is another hydroxyl group. So now we are getting this type of carbocation. When it react, we are getting a carbon with a positively charged species. Carbocation will be formed. Now in this carbocation, hydrozoic acid will attack on this. This is a best nucleophile. It will attack on it. When this attack, we are getting this type of structure. Structure we can write in this way. Here now carbon with a two hydroxyl group. There is a one hydroxyl group and this is another hydroxyl group. Now this nitrogen having a hydrogen here and here nitrogen double bond, or we can say nitrogen triple bond with the positive charge and here electron pair. So now this structure will be obtained. Now further, it is observed that we have taken a sulfuric acid. So in the presence of sulfuric acid, dehydration occur from here H plus and from here hydroxyl group will remove in the form of water. And here this electron pair given to carbon, so carbon oxygen double bond will form. So we get this structure RC double bond O. Here now nitrogen having this hydrogen and triple bond and nitrogen having a positive charge. So now when we heat these structures, the best living group of world is nitrogen gas. This electron pair will be taken by nitrogen. It will remove in the form of nitrogen gas. And we get this structure RC double bond O. This nitrogen having a hydrogen. Now this nitrogen having hydrogen, and with this it has a positive charge. It has a positive charge. Now this bond electron pair is taken by this nitrogen. So nitrogen will get a positive charge. So now this nitrogen having a positive charge, so in order to obtain stability, it will take electron from this bond. So this bond electron transfer on nitrogen, and as a result, this bond electron transfer on nitrogen, so H plus ion loss will occur, and we get this type of structure. Now RC double bond O, nitrogen, it has a one non-bonding electron pair was already there. Now this hydrogen electron pair also taken, so we get this structure which is known as a nitrene. Now whatever nitrene obtained, it is unstable, so in order to obtain stability, nitrogen give electron pair to carbon, and here this electron pair, alkyl group with electron pair transfer on nitrogen. So as a result, we will get these structures R, N, double bond C and double bond O, and this structure is known as a isocyanate. So this isocyanate is obtained, and now you know very well this isocyanate on hydrolysis in the presence of water. On hydrolysis, it is observed that from here carbon dioxide group will remove, and as a result we get a primary amine. So it is observed that we get this primary amine from carboxylic acid. We have started with the carboxylic acid. So carboxylic acid is converted into primary amine with one carbon atom less. Now suppose your question that how isocyanate is converted into primary amine, then in Hofmann rearrangement reaction we have already discussed that hydroxyl group attack on this, it is converted into carbazoic acid, and carbazoic acid further decarboxylation gives us a negatively charged species on nitrogen, and further it gives a primary amine. So एक बार आप Hofmann rearrangement reaction सारा देख लीजिए, यह स्टेप फिर रिपीट करने की जरूरत नहीं है यहाँ पर. So watch this video Hofmann rearrangement reactions. उसमें आपको पता चल जाएगा isocyanate is converting into primary amine in two steps. So once again, how this reaction occurs? Schmidt reaction is used to convert carboxylic acid into primary amine. In this reaction, carboxylic acid is reacted with hydroxylic acid in the presence of concentrated sulfuric acid. Now in sulfuric acid giving us H plus ion which approach to oxygens. So on protonations it gives this type of ion, RC double bond OH OH. This pi bond will break, electron transfer on oxygen, oxygen give electron to hydrogen. Now this hydroxylic acid, this nitrogen will approach to carbon, and we are getting this type of structure. From this, water will eliminate and we are getting these structures. Now hitting on this structure, we are getting this nitrogen with the best leaving group, it will remove and we get this type of structures. Now here nitrogen having a positive charge, in order to obtain stability, this hydrogen will lost, electron pair will be transferred on nitrogen, and we are getting a nitrene. Now nitrene, nitrogen having a 2 electron pair. It has a 2 electron pair. So in order to obtain stability, here nitrogen give electron to carbon, and this alkyl group with electron transfer on nitrogen. So now this nitrogen having a 3 bond and 1 electron pair. This structure is known as a isocyanate, and you are knowing very well isocyanate on hydrolysis, this carbon dioxide will remove and we get a primary amine. So by using this method, one can convert carboxylic acid into primary amine. Now Schmidt reaction is also used for ketone. By using this structure, that it is observed that ketone converted into, okay, now in next part application of this we will study. Now variety of application of Schmidt reactions. Now Schmidt reactions, carboxyl group, COOH group directly converting into amine NH2, and condition is N3H hydroxylic acid in the presence of concentrated sulfuric acid. So now first applications. Now we have this structure COOH and here CH3. Now this structure is known as para-toluic acid. Now this para-toluic acid allowed to react with hydroxylic acid in the presence of concentrated sulfuric acid. So now very simple thing. Now mechanism you are knowing very well. So what happened that when N3H and concentrated sulfuric acid is there, COOH group converting into NH2 group, and we get this product. So structure will be obtained is known as a para-toluene. It is considered as a para-toluene. Para-toluene will be obtained, or we can write this 4-amino-toluene. We can write. Now second, suppose we have this type of phenyl acetic acid. Now this is the structure of phenyl acetic acid. Now same condition, no any change for phenyl acetic acid. This condition is given that N3H and concentrated sulfuric acid. We are hitting this solution. Then simple things, carboxyl group according to mechanism will convert into NH2 via isocyanate. So we can write product of this reactions. This product will be obtained CH2 and H2, and this structure is known as a benzyl amine. So by using this simple way, we can convert carboxyl group into NH2 group, and whatever amine obtained, primary amine has a 1 carbon atom less as compared to carboxylic acid. Suppose third application, we have this structure CH2, CH2, COOH, COOH. Now what is the name of structure? You are knowing very well, it is known as succinic acid or butadioic acid. Now this is succinic acid. Now succinic acid allowed to react with this N3H and reaction condition concentrated sulfuric acid. So now what happens that this carboxyl group will convert it into NH2 group, and as a result we will get this structure CH2, NH2, NH2, and this structure is known as ethane 1,2 diamine, or we can say ethylene diamine. This ethylene diamine will be obtained. यदि आपको mechanism पता है, then you can write very easily this product. Now ketone also converted into this different type of product. Ketone also giving us Schmidt reactions, but product is a little different. Suppose we have this ketone. Ketone is allowed to react with a hydroxylic acid in the presence of concentrated sulfuric acid. Now when we hit this structure, it is observed that nitrogen will remove. Nitrogen gas will remove, and we get this type of structure RC double bond O and H and R dash. So this type of N-alkyl amide will be obtained. So it is observed that ketone also giving us this type of reactions. For example, we have taken this structure benzene ring and oxygen. So it is considered as a cyclohexanone. Now this cyclohexanone, same reaction condition N3H and hydroxylic acid in the presence of concentrated sulfuric acid, and we are hitting these things. So what happens that this in between these two, this bond will break, in between these two, according to mechanism NH will enter, and as a result we get this type of structure CONH. We can write CO and H, and here CH2 5 times. This structure we can write in this way also. We can write this structure in this way also. You can check this number of carbon atom 1, 2, 3, 4, 5, here 6 and here 7. So as a result we will get a 7-membered ring. This is 7. So this structure whatever obtained to us, it is known as a caprolactam. Now you are knowing very well, caprolactam is the most important thing. Nylon 6 polymer can be obtained from caprolactams. So in today's lecture we have studied how carboxylic acid can be converted into primary amine. This reaction is known as Schmidt reactions. In Schmidt reactions, carboxylic acid converted into primary amine having a 1 carbon atom less. It has a specific mechanism pata, then you can write different product based on these applications. So students, how you like my lecture? कैसा लगा आपको? अच्छा लगा तो लाइक करें, शेयर करें और सब्सक्राइब करना मत भूलिएगा.